Hey, this is the video for 1.4, Bright Line Spectrum. So go ahead and set up a new entry in your Cornell notes. Remember to start a new page for this video. Also check out the essential vocabulary. Today we'll be discussing Bright Line Spectrum. So just to review, the visible light spectrum is the light that is visible to humans. We have other lights at varying wavelengths. We have infrared light, which is beyond the visible light spectrum. We have ultraviolet, which is beyond this end of the visible light spectrum. You don't have to know what wavelengths these are. Wavelengths is the size of the waves, and you don't have to know that because that's physics, that's not high school chemistry. What you do have to understand, and this is a review, is that we have, whenever we add energy to an atom or an electron at the ground state, it will move to the excited state. So when you have this ground state electron, give it some energy, it's going to move to an excited state. Now, when it's at the excited state and it loses energy, it's going to go back to the ground state. But when it loses that energy's actually given off in the form of light. So this is something you should write down, and this should be a response. You just have to memorize this. But when an electron moves from an excited state to a ground state, energy is released in the form of light. Again, when electrons move from excited to ground state, energy is removed or released in the form of light. That is the basis of this. And each electron or each element is going to be different. And the wavelengths at which they release their light is called the bright line spectrum or the emission spectrum. So for example, if you look at hydrogen, it has wavelengths. These are the wavelengths that the light is released. If you look at sodium, sodium releases light at these wavelengths. Each element on the periodic table is going to release different amounts or different wavelengths of light. One thing that they do is how they can determine the sun is made up of mostly hydrogen and helium is they can look at the light with a spectroscope, and that will analyze the wavelengths of the light that is released. So then what they do is they kind of compare those wavelengths with known wavelengths of known elements, and that's how they have determined that. Now, what you will have to do is you may get 4 different samples, and this is the example light wavelengths that have been emitted, and then you may have an unknown sample. So this unknown sample basically contains the wavelengths from which 2 samples. So as you look through, basically what you have to do is you have to compare. So I see that C is out because I don't have anything from C in this one. As I look, this one is missing from D. But now I look, it looks like it's A and B, so let's just prove that. So A, we have, this one is here, this blue one. This is purple because it's found in both of them. This one from A is found in the unknown, this one from B, these 2 from B are found in the unknown, this one from A, and this one from B. So the unknown sample contains elements A and B, and you don't have to know what they are. If you are given actual names of elements, then great. We're going to be doing some practice like this in class. So I would like you to respond to this check for understanding. I hope that this video was informative. I thank you for your patience, and I will see you soon.